Hi, my name is Maria Jose Jimenez, and this is my lab report for Physics 2211. This lab covers Newton's second law and the momentum principle. Today's objective is to observe the motion of an object, in my case a thermos, moving at the same speed without changing direction, and analyze it computationally through GlowScript, using physics principles. With this, we will be able to predict a position versus time model. The principles applied in today's lab were the law of inertia, which states that an object in motion will stay in motion unless acted by an unbalanced force, and the momentum principle that explains that the force applied to an object is equal to the object's mass times its acceleration. In other words, that the change in momentum is equal to the mass of the object times its change in velocity. If an object is traveling at constant velocity, there is no net force applied and no net change in an object's momentum. The equations that we will use for the lab include the velocity update formula, the position update formula, and the average velocity formula. The position update formula says that the final velocity is equal to the initial velocity plus the net force divided by the mass multiplied by delta t. The position update formula states that the final position is equal to the average velocity multiplied by delta t. And the average velocity formula says that the average velocity is the displacement over delta t. For my calculations, I used Tracker. I uploaded my video and went timeframe by timeframe plotting the points. With this, I was able to find my initial position, and using the average velocity formula, I was able to find my initial velocity. This is my video. Here we can observe that the thermos moves at constant velocity and how the points were plotted. These are the points that are plotted, and up here we can observe the x-axis in regards to the time. For the predictions, I wrote my formulas in GlowScript. This is the program, and using Python, I was able to put the position of the ball, the velocity of the ball, and added the velocity formula and the position formula to do the predictions. When I run this program, we can see the distance that the ball traveled into the negative x-axis. And here we can see the time and position graph. This allowed me to construct a computational model to form a prediction versus time graph. I utilized both the GlowScript computational model and the Track experimental model and compared them. We can observe in this Excel that both the experimental and computational model support the claim that the thermos was moving at a constant velocity. This means that there was no change in momentum and no acceleration of the object, which also says that there is no net force being applied on that object. We can see how close the tracker and computational model look. We can also observe a negative slope. However, we can slightly see that as time progresses, the slope of the observed motion flattens, indicating a slight decrease in the velocity of the object. This indicates a coefficient of friction. We can wonder, what if we had flipped the x-axis? If we had flipped the x-axis, our conclusions would have remained the same. The main difference is that the slope would have been positive, and the direction would be positive, because we would be going towards the positive x-axis. What does it mean? We can't really say what made all the forces sum up to zero, because there were a lot of forces that we didn't take into account. We know that there was a gravity force and the normal force, but we also have friction. Friction, like I previously mentioned, could have been a force in this experiment because as the bottle went down after the camera, as they kept going, it would have slowed down time by time because of the coefficient of friction. Thank you.